Good morning, students. Today we are going to cover two more properties. First one, chain scale property, and second one, second shifting theorem of Laplace transforms. So what we covered up to now is we covered first we define Laplace transform, and we given 8 standard formula of Laplace transform. Then we went for properties. First of all, we given a linear property. Statement it may come for 1 mark, and problem on linear property it may come for 3 marks. Then we given a first shifting theorem of Laplace transforms. So in this class, what we are going to learn is chain scale property and second shifting theorem or second shifting property of Laplace transforms. So this is what we are going to learn. So the first one is change scale property. It comes for 3 marks. Problem comes for 3 marks if it comes, but actually many times no problem for change scale property and second shifting theorem. So mostly we will get problems from linear property of Laplace transform and first shifting theorem, problems on first shifting theorem, and problems from multiplication by t square divided by t, evaluation of integrals, all those on those topics we will get problems. But this chain scale property and second shifting theorem is, as far as marks considered, they are less important. I would say they are less important, rather they are lesser important than the previous topics, the previous two properties. So let us move on to the topic chain scale property. So what is the chain scale property? Yes, the chain scale property is given as if L of f of t is equal to f bar of s, then L of f of a t is equal to 1 by a into f bar of s by a. This is why this is called chain scale property. You can really say here it is t, here it is a into t. It is constant multiply, is a constant. It is multiplied by a, t is multiplied by a t. That's why there is a change in a scale. That's why it is called chain scale property. So remember, where is the property? What it says, if L of f of t is equal to f bar of s, then a into t, f of a t is 1 by a into s, f bar of s by a. So at place of s we are writing what we are writing, s by a. At place of s we have to write s by a multiplied by 1 by a, that is 1 by a into f bar of s by a, 1 by a into f bar of s by a. At place of s we have to write s by a multiplied by a constant 1 by a. So very simple property, change scale property. If L of f of t is equal to f bar of s, then L of f of a t is 1 by a into f bar of s by a. So this is the property, change scale property. Let us go to the problems. So statement may come from 1 mark like this. State chain scale property. What you have to write? State chain scale property. What we need to write then? So if L of f of t is equal to f bar of s, then L of f of a t is equal to 1 by a into f bar of s by a. So at place of s you have to write s by a multiplied by 1 by a constant. This is our chain scale property, guys. Read so that we can go on to the problems. Straightly we will move to the problems. Are getting? So first of all we learned the linear property of Laplace transform. What linear property says, whenever the constants are inside the Laplace transform we can take those constants outside. And then first shifting property, it gives answer to the question whether product rule exists in Laplace transform. As product rule exists only in particular cases, the special case one is first shifting theorem. What it says, product of two functions, among them one is exponential. If it is e power of a t, one of the function in its product of functions, if one of the function is e power of a t, then replace s by s minus a. If it is e power of minus a t, replace s by s plus a. That is our first shifting theorem. Now coming to the chain scale property, what it says, L of f of t is equal to f bar of s. Then L of f of a t is equal to 1 by a into f bar of s by a. So this is our property. Read once. Let us go to the next problem. Problems, chain scale property problems on chain scale property, very easy problems, but if they come for 3 or 5 marks in examination. So let us go for problems now. Are you ready? Let us move to the problems. So this is chain scale property. One more time I am repeating, chain scale property of Laplace transform. Third property we are defining. What is that? If L of f of t is equal to f bar of s, then L of f of a t is equal to 1 by a into f bar of s by a. Are you getting it? So this is, so let us move on to the problems. What the problem says, if L of f of t is equal to s square minus s plus 1 by 2s plus 1 whole square into s minus 1, then find L of f of 2t. There is a change in a scale. You see what is given, Laplace transform f of t is given. You have to find Laplace transform of f of 2t. It is multiplied by 2. Clearly it is a problem from chain scale property. Very easy to identify. Are able to get it? Very easy to identify. It is given that L of f of t is given. Now you have to find L of f of 2t. It is t is multiplied by 2. Therefore there is a change in a scale. That's why the problem is from chain scale property. This is our first problem. Write down the problem, guys. If L of f of t is equal to s square minus s plus 1 by 2s plus 1 whole square into s minus 1, then find L of f of 2t. So let us go to the problem. So what the problem says, it's given, what is given, L of f of t. What is L of f of t? It is given s square minus s plus 1 by 2s plus 1 whole square into s minus 1. That is given thing. Say it is f bar of s. So what is the given thing? L of f of t. L of f of t is given. What is that? S square minus s plus 1 by 2s plus 1 whole square into s minus 1, which is f bar of s. Now what is asked? What is asked? L of f of 2t. Instead of 2 there is 2t, that is multiplied by 2, means there is a change in a scale. That's why the problem comes under chain scale property. Very easy to identify the problem. Nothing is there in the problem. So L of f of 2t. What is L of f of at? In chain scale property we given L of f of 8. L of f of 8 is 1 by a f bar of s by a. Instead of 80, now you are having 2t. Therefore L of f of 2t is 1 by 2 into f bar of s by 2. So this is the thing by change scale property. This is what we have to find. We have the formula for finding L of f of 2t by using chain scale property. So what is L of f of 2t is 1 by 2 f bar of s by 2. 1 by 2 f bar of s by 2 by change scale property. So what is f bar of s? We have f bar of s. This is f bar of s. This is our f bar of s. Now we need f bar of s by 2. We know we have f bar of s, but in the formula what we have in 1 by 2 into f bar of s by 2, we need f bar of s by 2. So at place of s, write down s by 2. At place of s, let us put s by 2 multiplied by 1 by 2. So 1 by 2 constant into, at place of s, let us write s by 2. So what happens? S by 2 whole square minus s by 2 plus 1. S by 2 whole square minus s by 2 plus 1 by 2 into s by 2 plus 1 whole square s by 2 minus 1. In the numerator let us take LCM 4 common, what you get? S square minus 2s plus 4 by 4, and denominator also let us take 2 LCM common, what will get? S plus 1 whole square into s minus 2 by 2, cross multiply. So you will get the answer is s square minus 2s plus 4 by 4 into s plus 1 whole square into s minus 2. The problem, if it is comes for 3 marks or 5 marks, it is come very easy problem, nothing is there. You can easily identify the problem because it is what is given. L of f of t is given as L of f of t is given, and what is asked? He is asked us to find L of f of 2t. So 2t, L of f of t given, L of f of 2t is asking. There is a certainly change in a scale, so it comes under change scale property. So L of f of t is given, say it is f bar of s. Now you have to find L of f of 2t, that is 1 by 2 into f bar of s by 2. So 1 by 2 into, at place of s you have to write s by 2. So replace s by 2 and simplify, take LCM and cancel numerators and denominator, the common factors, then simplify to get L of f of 2t. What is answer? S square minus 2s plus 4 by 4 into s plus 1 whole square into s minus 2. So this is our first problem. Take it down, guys. Change scale property, if it comes for 3 marks. So this is our problem. The first problem, if L of f of t is s square minus s plus 1 by 2s plus 1 whole square into s minus 1, then find L of f of 2t. So this is our first problem on change scale property. Are able to get it? Very easy to identify the problem and very easy to solve the problem also by remember the formula L of f of at. What is L of f of at? It is 1 by a into f bar of s by a. So let us go to the next problem. Take it down so that we can move on to the next problem, guys. Lot many problems we have to do, so let us move on to the next problem. If L of f of t is equal to 20 minus 4s by s square minus 4s plus 20, find L of f of 3t. So what is asking? It is given. L of f of t is given. Now he is asking us to find L of f of 3t. So t is multiplied by 3. 3t is asking f of 3t. L of f of 3t, it comes under change scale property. So what is given? L of f of t. So this is our f bar of s, 20 minus 4s by s square minus 4s plus 20. Let us say it is f bar of s. Now L of f of 3t by change scale property, L of f of at is 1 by a f bar of s by a. 1 by a f bar of s by a. Now L of f of 3t we are having. L of f of 3t means 1 by 3 f bar of s by 3. 1 by 3 into f bar of s by 3. So 1 by 3, it is a constant. Now f bar of s by 3, we are having f bar of s. This is L of f of t, that is our f bar of s. Now what we need? We need f bar of s by 3. So at place of s, put s by 3. So replace s by 3. Are able to get it? We are having L of f of t 20 minus 4s by s square minus 4s plus 20, which is our f bar of s. Now we need 1 by 3 into f bar of s by 3. 1 by 3 constant. Outside we need f bar of s by 3. So in a f bar of s, replace s by 3. So what is that? You will get 20 minus 4 at place of s by 3. 20 minus 4 into s by 3 by s by 3 whole square minus 4 into s by 3 plus 20. Take in numerator 3 common, 3 LCM, 60 minus 4s. In denominator s by 3 whole square, s square by 9 it is. So what is LCM? Our LCM becomes 9 s square minus 12s plus 9 into 20, it is 180. So what is that? 60 minus 4s by 3 numerator and denominator is s square minus 12s plus 18 by 9. Then cancel equal factors 3 1 ja 3 3 ja and 3 1 ja 3 1 ja 9 and 9 cancel in numerator denominator. So what is answer? The answer is 60 minus 4s by s square minus 12s plus 180. So this is our answer. 1 by 3 into f bar of s by 3. L of f of 3t is 1 by 3 into f bar of s by 3. So what is our final answer is 60 minus 4s by s square plus s square minus 12s plus 180. Very easy. So if you know the formula, that is change scale property, if you know the change scale property, then it is very easy to solve the problem. Just at place of s, you have to write s by a multiplied by 1 by a constant. So this is our second problem on change scale property. So all problems are of same type, so no need of more problems on change scale property. I think just reply his in the problem it is given f bar of s. In solution we need f bar of s by a, so replace s by a and simplify that, you get answer. So nothing much to do in this change scale property. Very easy problem. So I given solution of two problems. I think it is enough on change scale property. So let us go on to the next. What we need to learn is, okay, how much? Only 30 minutes left. So let us go to the second shifting theorem. Before second shifting theorem, we need to learn what is unit step function. So first of all, let us learn unit step function. So what is unit step function? How it is defined? Unit step function. How unit step function is defined? So the unit step function is denoted by, what is a notation for unit step function? It is denoted by u of, u means first letter unit. Unit step function is denoted by u of t minus a. It is a notation for unit step function. And how it is defined? If t is less than a, the value is 0, and if t is greater than a, the value is 1. If we say this is the value a, then for less than 0 it is 0, for less than a it is 0, and for greater than a it is 1. So it looks like steps. And what is the distance? Distance is 1. That's why it is called unit step function. It is called unit. What is the distance? It is a 1. And it look like steps. That's why it is called unit step function. If you take the graph, I am clearly giving the graph of unit step function. It is a stepwise steps. It looks. That's why it's a step function, and the distance is 1. Therefore, it is unit step function. So how it is defined? Unit step function denoted by u of t minus a, and for t less than a it is 0, and for t greater than a it is 1. So this is our unit step function. Are you able to get it? So I'm clearing this unit step function. One more time I am giving for you, repeating for you. The unit step function is denoted by, this is a notation. What is the notation, guys? U of t minus a is our notation, denotation for unit step function, and it is defined by, how it is defined, guys? U of t minus a is equal to t less than a, means it is 0, and for t greater than a it is 1. And if you take the graph, below I given the graph also. If you take the graph is looking as steps. That's why it is a step function, and the distance between the steps is 1 unit. One is called unit. That's why unity. So therefore the function is named as unit step function. Are you able to get it? So this is a definition of unit step function. So most usually what the question comes in examination is define unit step function. This is what we defined here. Define unit step function and find the Laplace transform of unit step function. That comes in for 5 marks. Previous question for 5 marks. How many? 5 marks. So what is that? What is that is define unit step function and find its Laplace transform. Now we are given what is unit step function, how it is denoted, u of t minus 1, and how it is defined. For t less than a, it is 0, and t greater than a, it is 1. The graph is steps and distance is 1. Therefore, it is called unit step function. What we have to do now? This is unit step function we are given, but now we have to find Laplace transform of unit step function which comes for 5 marks. So note it down so that we can go to what you have to find now. Laplace transform of unit step function. This is the definition we given, notation given, graph is given, everything is given about unit step function. Now let us find Laplace transform of unit step function. So Laplace transform of unit step function u of t minus a, u of t minus a. So which came previously for 5 marks. So shall we go? Laplace transform of u of t minus a, that is L of Laplace transform denoted as capital L. So L of u of t minus a is equal to definition. What is the definition? L of f of t. What is Laplace transform of f of t? Laplace transform of L of f of t is integration 0 to infinity e power of minus st into f of t dt. Now instead of L of f of t, now we are having L of u of t minus a, that at place of f of t, you have to write u of t minus a. Therefore, what is Laplace transform of unit step function is integration 0 to infinity e power of minus st into u of t minus a into dt. But the limits of integration are 0 to infinity, 0 to infinity. But 0 to a, the unit step function is 0, and a to infinity, the unit step function is 1. Therefore, we divide the integral into two parts, 0 to a and plus a to infinity. In 0 to a, unit function is 0, and in a to infinity, unit step function is 1. Are you able to get it? What we are doing? What we are doing here, are you able to get it? The limits are 0 to infinity. But 0 to infinity, unit step function is not having the same value. 0 to a, it is 0, and 0 a to infinity, it is 1. So we are dividing the integral into two parts, 0 to a plus a to infinity. The first integral becomes 0 because 0 into something is 0. Now second integral. What is the second integral? The second integral is e power of ax. Integration of e power of ax is e power of ax by a, x coefficient a. Now it is in terms of dt, t, e power of minus st integration, e power of minus st by minus s, e power of minus st by minus s from a to infinity. Upper limit minus of lower limit. Let us take constant outside minus 1 by s outside. Now upper limit at place of t, write infinity minus s into infinity minus infinity e power of minus infinity minus e power of minus as. At place of t, you have to write a. Upper limit minus of lower limit, it is minus 1 by s into e power of minus infinity minus e power of minus as. What is e power of infinity? E power of infinity is infinity. Therefore, e power of minus infinity will be 0. E power of minus infinity means 1 by e power of infinity. That is 1 by infinity. 1 by infinity becomes 0. So, e power of minus infinity 0 means what is the answer? Answer is e power of minus as by s. What is this? What is this? E power of a minus as by s is our Laplace transform of unit step function given previously for 5 marks. Are you able to get it? Very easy. What we are doing, depending on the definition, we are finding Laplace transform unit step function. So by definition of a Laplace transform, L of u of t minus a is equal to integration 0 to infinity e power of minus st into u of t minus a. But u of t minus a is not same over all the interval 0 to infinity. It is 0 from 0 to a and it is 1 from a to infinity. That's why we are dividing the integral into two parts, 0 to a and a to infinity. In 0 to a it is 0, so no need of first integral, only second integral a to infinity e power of minus st dt. Integration of e power of ax is e power of ax by a, e power of minus st integration e power of minus st by minus s, minus 1 by s outside. Now upper limit minus of lower limit, at place of t you have to write infinity, minus of at place of t you have to write a, but e power of minus infinity value 0. Therefore the answer is e power of minus as by yes. So what is a Laplace transform of unit step function is L of u of t minus a is equal to e power of minus as by s. So take down this. So this is our definition of a unit step function. It is denoted by u of t minus a and defined as for t less than a it is 0, for t greater than a values it is 1. Given a graph, it look like steps and distance is unity, therefore it is called unit step function. And depending on the definition of Laplace transform and unit step function, we got Laplace transform of unit step function. What is that? L of u of t minus a is equal to e power of minus as by yes. So this is our unit step function and its Laplace transform. Now depending on unit step function and its Laplace transform, let us give second shifting theorem. So let us go to, so what we covered, change scale property and unit step function, its Laplace transform. Now the second part of the class is, what is that? Second shifting theorem. So look for the time as 20 minutes more. So let us complete the second shifting theorem and its problems in this class. So quickly let us move on to the second shifting theorem of Laplace transform. So how it is defined, what is a property, what is the theorem says, and corresponding problems. Let us try to learn in this video the second shifting theorem of Laplace transforms. What it says, you see, if L of f of t is equal to f bar of s, so Laplace transform of f of t is given and it is f bar of s, and g of t is defined as for t less than a it is 0 and for t greater than a it is f of t minus a, just like unit step function, very similar to unit step function. So in the unit step function, what we got? E power of minus a s by yes, that is e power of minus a s into 1 by s, that is f bar of 1, L of 1. Now L of f of t, f bar of s. So it's very similar way it is defined, g of t. Therefore Laplace transform of g of t is e power of minus as into Laplace transform of f of t, that is f bar of s. So remember, this is our second shifting theorem. What it says, L of g of t is equal to e power of minus as into f bar of s, e power of minus as into f bar of s. F bar of s is given and e power of minus as into f bar of s, that's what we need to find. Are getting? So it is very, first of all we define unit step function, because by using unit step function it is very easy to understand the second shifting theorem. So this is our second shifting theorem. Quickly let us go to what we have to do now, problems. Let us go for problems. Problems on second shifting theorem. Problems on second shifting theorem. Yes, we have to finish it up. You see, the first problem. Find L of g of t. You have to find Laplace transform of g of t. But g of t, how it is defined g of t? It is 0 for t less than 4 and it is t minus 4 whole cube for t greater than 4. So comparing, what you will get? A value is 4. What is A? In definition, we are given t less than a and t greater than a. Now t less than 4 and t greater than 4. Therefore, a is equal to 4. And at place of f of t minus a, at place of f of t minus a, we are having t minus 4 whole cube. So f of t minus 4 is t minus 4 whole cube. So if it is t minus 4, then it is t minus 4 whole cube. So therefore, if it is t, then it is t cube. So this step we need to find. So from the problem, what we got? We got that f of t minus 4 is equal to t minus 4 whole cube. By saying that at place of t minus 4, you have to write t. F of t minus 4 is there. Now you need to find f of t. Here you can see f of t. So at place of t minus 4, just write t. That gives f of t is equal to t cube. That's what we need to find. Once if you are able to find f of t, that problem ends here. So f of t is equal to t cube, L of f of t, that is L of t cube, L of t power of n, standard formula. So I am repeatedly told you that you have to remember all those 8 standard formulas of Laplace transform. Now L of t power of n is n factorial by s power of n plus 1. Now L of t cube is 3 factorial by s power of 4. 3 factorial is 1 into 2 into 3, that is 6. Therefore L of t cube is 6 into s to the power of 4, that is our f bar of s. Now we are able to find f bar of s by second shifting theorem. L of g of t is e power of minus as into f bar of s. What is a? A is 4. What is f bar of s? It is 6 by s to the power of 4. So what is answer? Answer is e power of minus 4s into 6 by s to the power of 4. So from the problem we got f of t minus 4. If you are able to find f of t, then problem ours. Find Laplace transform of f of t and substitute in second shifting theorem. That gives our answer. So what is answer? L of g of t is e power of minus 4s by 6 into s to the power of 4. So this is our first problem on second shifting theorem. How much time left? It is 15 minutes. So let us quickly move on to the next problems. Try to solve as many problems as we can. So this is the second problem of on second shifting theorem. What it says? Find L of g of t, where g of t is very similar. For t less than a, it is 0. For t greater than a, it is e power of t minus a. So comparing with the theorem, what is a value? At place of a, we are having a, t less than a, t greater than a. And at place of f of t minus a, we are having e power of t minus a. So from the problem, what will got? F of t minus a is e power of t minus a. At place of t minus a, if you substitute to t, you get f of t is equal to e power of t. This step we need. Once you are able to get this step, then the problem completes. Are getting from the question itself, you are getting f of t minus a. What is f of t minus a? E power of t minus a. Now at place of t minus a, substitute t. What you get? F of t is equal to e power of t. We got f of t is equal to e power of t. Now L of f of t, that is L of e power of t. Again standard formula. What is the standard formula we are using here? L of e power of at. L of e power of at is 1 by s minus a. Now L of e power of t is 1 by s minus 1. This is a power of s. Now by second shifting theorem, L of g of t is e power of minus as into f bar of s. At place of a, we are having a, and f bar of s is 1 by s minus a. So what is our answer? Is L of g of t. L of g of t is e power of minus as into 1 by s minus 1. So this is our solution for second problem on second shifting theorem. So from the problem we are able to find f of t minus a. at plus of t minus a, substitute t to get f of t, then find L of f of t, that is f bar of s we are able to find, then substitute a value and f bar of s in second shifting theorem, that gives answer. This is our problem. So note it down so that we quickly move on to the next problem. So this is our next problem on second shifting theorem. What it says, what is the problem? Find L of g of t, where g of t is 0 if t less than pi by 2, and if it is t greater than pi by 2, it is cos of t minus pi by 2. What is a value? For t less than a and for t greater than a, instead of less than a greater than a, we are having t less than pi by 2 and t greater than pi by 2. So very easily by observing the problem, we are able to get a is equal to pi by 2, and f of t minus pi by 2 is cos of t minus pi by 2 at place of t minus pi by 2, substitute t to get f of t. What is f of t? F of t minus pi by 2 is cos of t minus pi by 2, therefore f of t is cos t. This is the step we need to get. F of t we got. What is f of t? F of t is equal to cos t. Now L of f of t, that is L of cos t. What is a standard formula again? So in every problem the formulas are coming. So that's why I said many times that you have to buy all those formulas. Now L of cos at. What is L of cos at? S by s square plus s square. Now what is L of cos t? S by s square plus 1 square, that is 1. So f bar of s is s by s square plus 1. S by s square plus 1. So substitute this. What is a value? Pi by 2. And what is f bar of s? It is s by s square plus 1. By second shifting theorem, what we are having, L of g of t is e power of minus s into f bar of s. At place of a, pi by 2, and f bar of s, at place of f bar of s, you have to write s by s square plus 1. So L of g of t is equal to, what will get, e power of minus pi by 2 into s by s square plus 1. So this is our third problem on second shifting theorem. What the time left is 10 minutes. Let us move fast to solve more problems. So this is our next problem. Find L of g of t, where g of t is 0 if t less than 2 pi by 3, and for t greater than 2 pi by 3, it is cos of t minus 2 pi by 3. So comparing t less than 2 pi by 3, t greater than 2 pi by 3, instead of a, what you are having, it is instead of a we are having 2 pi by 3, instead of f of t minus a, that is you are having cos of t minus 2 pi by 3. So f of t minus 2 pi by 3 is cos of t minus 2 pi by 3 at place of t minus 2 pi by 3, substitute t to get the question. To get the important thing is, what is that? F of t is cos t. What is L of f of t? That is L of cos t. L of cos at, s by s square plus s square. L of cos t, s by s square plus 1. This is f bar of s. Now substitute in f bar of s. In second shifting theorem, what is a value? 2 pi by 3. What is f bar of s? S by s square plus 1. That's so the answer is L of g of t is e power of minus 2 pi by 3 into s by s square plus 1. Very similar to third problem. Very easy problem. So very easy one. So that is, let us go to the fifth problem. What is that? Find L of g of t, where g of t is equal to 0 if t less than pi by 3, and it is sin t minus pi by 3 if t greater than pi by 3. For t less than a and for t greater than a, we have in second shifting theorem t less than a, t greater than a. Instead of a, we are having here pi by 3. So what is the a value? A value is pi by 3. And instead of f of t minus a, we are having sin of t minus pi by 3. So a is pi by 3 and f of t minus pi by 3 is sin of t minus pi by 3. At place of t minus pi by 3, substitute t, you get f of t is equal to sin t. What is f of t? F of t is sin t. Are you able to get it? You need to get this one. From the problem, you are having f of t minus a equal to pi by 3. So, f of t minus pi by 3. From problem itself, you are getting sin of t minus pi by 3. So, now instead of f of t minus pi by 3, we need f of t. So, replace t minus pi by 3 by t. You get f of t is equal to sin t. L of f of t, that is L of sin t. What is the standard formula? L of sin a t, a by s square plus a square. L of sin t, 1 by s square plus 1. This is a power of s. In second shifting theorem, put a value and a power of s value. So what will get? L of g of t is equal to e power of minus pi by 3 into s into 1 by s square plus 1. So this is our fifth problem on second shifting theorem. Are you able to get it? So from the problem, you are having f of t minus pi by 3, that is this. At place of t minus pi by 3, put to t, you get f of t. Find L of f of t, you get f bar of s. You know a value and you know f bar of s. Substitute in second shifting theorem to get the answer. So this is our fifth problem. Can we cover one more problem? Yes, let us try to cover one more also. So this is our sixth problem. Find L of g of t, where g of t is equal to 0 if t less than b, and it is t minus b if t greater than b. Comparing with the theorem, there in the theorem we have t less than a, t greater than a. Now t less than b, t greater than b. So at place of a we are having b. Therefore a is equal to b. And f of t minus a, here f of t minus b is t minus b. So f of t minus b is equal to t minus b. At place of t minus b, if you write t, then we got f of t is equal to t. Are you able to get it? F of t is equal to t. F of t is equal to t. At place of t minus b, substitute t. So here t minus b, here also t. At place of t minus b, here also t. So f of t is equal to t we got. This is what we need to get. From the question itself, we get f of t minus a, here a equal to b, that is f of t minus b we got. Now from that you are able to find f of t. Now we got f of t is equal to t. What is L of f of t? That is L of t. L of t power of n is n factorial by s to the power of n plus 1. Now L of t power of 1 is 1 factorial by s square. 1 factorial is 1, that is 1 by s square. So 1 by s square is our f bar of s. Therefore, by second shifting theorem, what is L of g of t? E power of minus as into f bar of s. A is equal to b and f bar of s equal to 1 by s square. Substitute L of g of t is equal to e power of minus bs by 1 by s square. So this is the problem on second shifting theorem. This is the sixth problem on second shifting theorem. So what is the time left for us? Only 2-3 minutes, so we cannot go to the next problem. So enough problems. So what we did here, what we did, we given two important properties of Laplace transform. First one is change scale property. What change scale property says? L of f of at is 1 by a into f bar of s by a. We know f bar of s. Now we need to find 1 by a into f bar of s by a. Means at place of s, you have to write s by a multiplied by 1 by a. That's it. Very easy problems. That's why we given this change scale property, and we did only I think how many? Yes, we did only 2 problems, because all problems are very similar, and if the problem comes, it comes for 3 marks or 5 marks, and statement comes for 1 mark. That is change scale property. Then we went on to unit step function. We defined a unit step function. What is a unit step function for t less than a? It is 0, t greater than a, it is 1, denoted by u of t minus a. And we calculated, we find it out, what is a Laplace transform unit step function. U of L of u of t minus a is e power of minus as by s. That's we got Laplace transform of unit step function. So that's it's a previous question. Define unit step function and find its Laplace transform is a previous question for 5 marks. So we did it. Based on the unit step function, we defined second shifting theorem. after getting second shifting theorem, the next property. So first property will end linearity property, second one first shifting theorem, third one chain scale property, and the last one is second shifting theorem. In a second shifting theorem, we given a second shifting theorem the statement, and based on that we are able to cover how many few problems, how many, 6 we covered about this is the last problem which is I am showing on the slide. This is the 6th problem we covered. So we are able to cover 6 problems on second shifting theorem. So now it is a time to go for the homework. Yes, we need to give a homework. So let us go for the homework. So before the homework problem, I want to tell you one thing. So practice all these problems which we covered in this lesson. So first of all, very first thing we have to do is you have to by-heart all those 8 standard formulas of Laplace transform. After by-hearting, read the property, chain scale property, then practice the problems. Read what is unit step function, what it is Laplace transform, by unit step function how we given the second shifting theorem, what is the second shifting theorem, how we can find, how we can solve problems on second shifting theorem. So practice all those problems of second shifting theorem, then go for homework. Are able to get it? So this is the homework I am giving. Find L of g of t, where g of t is 0 for t less than pi by 2, and it is for t greater than pi by 2 it is e power of t minus pi by 2. So what is a value? A value is pi by 2, and f of t minus pi by 2 is e power of t minus pi by 2, and f of t is e power of t. Use the formula, standard formula, L of e power of 80, 1 by s minus a. So that gives answer, very easy. Second problem, find L of g of t, where g of t is 0 for t less than 2 pi by 3, and for t greater than 2 pi by 3 it is sine of t minus 2 pi by 3. By comparing, what is a value? 2 pi by 3. What is f of t minus 2 pi by 3? Sine of t minus 2. What is f of t? Sine t. That's it. Go on. You can easily find. So first of all, practice the solved questions in this video. Let you understand how we are solving. Once you can understand, you can go for homework problems, and you can do the homework problems. And for any queries, you can mail me on naresh.debadi@gmail.com, and do the practice the solved problems, then do the homework problems. You can ask any queries in Gmail, also in our Google Classroom. So after doing homework, post them in a Google Classroom so that I can respond quickly and I can verify easily. So practice the problems, then do the homework and post in the Google Classroom. So that's all for today, guys. So we covered another 2 properties, chain scale property and second shifting theorem. That's it, guys. Thank you very much. Stay home, stay safe, stay healthy. Thank you. See you tomorrow. Bye.